Hello students, welcome you all to the course in Compiler Design. In today's lecture, we will be seeing the SDT schemes. In the previous lecture, we have seen what SDT is. It is syntax directed translation. So it is part of the semantic analysis phase, and there are various schemes for the various constructs in the language. So that is what we are going to see today. First of all, we will see the SDT for assignment statements. So let us start with the grammar for assignment statements. We very well know the simple grammar for assignment statements. So we have the plus operator, multiplication operator, any other operators also we can include by additional rules. So this is the syntax directed translation, and with this we are generating expressions. So the expression can be of type real, integer, array or records, etc. So how do we go about the translation scheme? So once again we will start from the last production. We are having E arrow ID. So this is the identifier. Okay, whenever we come across an identifier, we have to find out whether the identifier is being declared or not. And the declaration part will be directly stored in our symbol table. So what we are trying to do here is, if I come across this E arrow ID, I have to go and look up in the symbol table whether the identifier is existing or not. So we write it as P equal to lookup of id dot name. So whatever identifier is there, we are using the lookup operator and checking whether it is existing in the table. So if it is not null, meaning it is existing, then I can emit. I can say that this variable is correct. So I can give the value. Whenever I come across this production, in place of id, I can replace it with the value that has been stored in the memory for that particular variable. In case it is null, then it means that it is an error. The variable has not been declared. So that is the syntax directed or the semantic action for the production E arrow ID. Then next, when I come to E arrow open bracket close bracket of E1, it is just an assignment statement. So whatever is in E1 dot place is being assigned to E dot place. It is very simple. When I come to the star and plus operator, both are arithmetic operations. So when I'm doing the multiplication or doing the addition, these are two different variables and we are assigning it to the third variable. Okay. So that is why we are creating a new variable. So E dot place is equal to new temp. A new temporary variable is created, and then we can emit the value as, so this is going to be this is generating the 3 address code. If you clearly see, this will be E dot place means this will be the variable value. This is going to be the value of E1, and the plus operator is put in single quote, meaning to say that has to appear. So the output of this, the right hand side part semantic action, will be nothing but it will be emitting the 3 address code. That is why we have put emit. It is going to generate the 3 address code for us. So instead of in multiplication we are using star, in addition we are using plus, and so on. When you come to the final production, here again S arrow ID, which is equal to E, means we have come to the end of the string. We have passed the entire string. So once again we are assigning the found out value, whatever the arithmetic expression what you evaluated, it is going to be in E, and that is going to be assigned to S. So once again I have to check whether it is existing in the symbol table. So the same type of checking will be done here also. So this is the syntax directed translation scheme for assignment statements. And we can see that P returns the entry for ID name in the symbol table. So we are using the variable. And then emit function is used for appending the 3 address code to the output file. Otherwise it will report an error. And new temp is a function to generate the new temporary variable. And E dot place holds the value of E. Next we move on to grammar for Boolean expressions. We know very well Boolean expressions include OR operator, AND operator, NOT operator, and all these Boolean operations are done only on the if conditions. So if the condition will be if identifier 1, identifier 2, in between we will have the relational operator. Okay, that is the structure for an if condition. So all this Boolean expressions happen only in the if condition. And it can be either the Boolean expression can evaluate to either a true value or a false value. And the relative operators can be less than, greater than, less than or equal to, greater than or equal to, equivalence, and not equal to. So we will try to write the SDT for Boolean expressions now. So it is very similar to our arithmetic expression. Whenever it is false, we are assigning to 0. The E dot place is 0. So we are creating a new variable, assigning the value as 0 if it is false. If it is true, we will always assign to the value 1. And we know very well that the fourth rule, E dot place is equal to E1 dot place. And this not, and, or are all similar to our arithmetic operation what we already saw. Instead of plus we are using OR operator, here we are using AND operator, and here NOT operator. So only new thing what we are seeing is this if condition, what we will come across in the if condition. So here again we are evaluating a new variable, so E dot place is equal to new temp, and initially we will generate the statement if id1 dot place relative operator id2 dot place go to next star plus 3. See, you can just recollect what we did in backpatching. When we studied backpatching, or when we wrote the 3-address code for if condition, let us take it that way. We did the 3-address code for if condition. So that time we wrote like this. First of all, we will write the if A greater than B. If it is true, we will go to the third statement. The very next statement will be the else condition, and the true condition will be followed by that. So that is what is this next star plus 3. And then the next statement is the false condition, as I told you. So we are putting it as 0. And after the false condition, we have to go to the remaining part of the program. So that is why we are saying next stat plus 2. And in the next statement, we will be doing the true statement. So you please refer with the if condition what we generated for 3-address code. Then you will be able to follow this particular explanation. Next we move on to case statements. So we can begin, we will have case 1, 2, 3, 4 up to n minus 1, and for each case we will have statements, and there will be a default case also. So how do we write the 3-address code or the translation scheme? So initially for everything there will be a code, okay, all the labels there will be code, and soon after the code we have to come to the remaining part of the program. That is what we are saying go to next. So initially I will be in this go to test. I will go to the test condition, and in test I will check whichever value, what is the value that I am getting in the case statement. So if it is V1, I will go to L1 label. If it is V2, I will go to L2, and so on. And once I finish the code, I have to come to the remaining part of the program. That will be the next value. So this will be the way I write my case statement SDT. Finally, we will see the SDT for control statements. You know very well control statements are of 3 types. We have the if then condition. If E then S1. Or we can have an if E then S1 else S2. So 2 conditions. We have a then condition and an else condition. And the third type of control statement is the while do loop or do while loop. And all these operations will evaluate to either a true condition or a false condition. So that is why the Boolean expression will be included in these control statements. So we will go through in detail. So you will first take the if then condition. So we have only two things. We have a expression, arithmetic expression or a Boolean expression. It is getting evaluated. If it is getting evaluated, it can be either a true or a false condition. So if it is true, I have something to do. So if E, then S1. If it is false, we are just going to continue with the remaining of the program. So there is no code here. We have not given any condition here for the else part. Okay. So the else part, we don't have any condition. So we are going to evaluate. When I evaluate the expression, it will be either a true value or a false value. If it is true, I have to do something. It is given here S1. And if it is false, there is nothing to do. So I can continue with the remaining of the code. Okay, so there is a label E dot true, a label E dot false. And here the true for label alone is valid because we will have some code for the true condition. And next, it has to follow with the next. So that is how we are going to write here. So you can see the syntax directed translation for E then S1. We need a new label for true alone because we are going to do some code. Okay. So we have a new label, and S1 dot next means it is going to go off next. So S code will be generated as, if it is true, we have to go to S1 code. Okay, the similar same thing only. We are, instead of emit, here it is written as generate. So we are generating the, if it is true condition, we are going to execute the S1 code. And after executing S1 code, S1 dot next, the remaining of the program. And false will automatically continue with the S dot next. Now moving on to E then S1 else S2. So we are going to have two codes, S1 code and S2 code. So if it is true, it is going to go and do S1 code. If it is false, it is going to do S2 code. And both ways, after doing it, it has to continue with the remaining of the program, which is S dot next. Okay. So after that, it is going to continue with S dot next. The same way we will write the SDT. So here we are creating two labels, one for the true, another for the false. And both of them have to go to the remaining of the program. Either it is true, I will execute S1. If it is false, I will execute S2, and then I have to continue with the remaining of the program. So S1 dot next is also S next, S2 dot next is also S next. Finally, we will see while E do S1. So another important constraint is the while do constraint. Here it is the same discussion. We are going to have either a true value or a false value. Only thing is here it is in a loop. So we will go back to S dot begin. We will keep on executing till the condition is false. If when it becomes false, I will continue with the remaining of the program. As long as it is true, it is going to keep on executing the code S1. So here also begin will be a new label, true will be a label, false will have no label because there is nothing to do but to continue with the remaining of the program. Whereas after the true value, we have to go to begin. It has to keep on looping there. Okay, so the code is generated. First begin is generated. Then if it is true, we are executing S code and we go to begin. When it becomes false, it will come out of the begin. It won't go back to the begin. So these are some of the important syntax directed translation schemes for the statements what we have seen so far. Assignment statements, Boolean expressions, and control statements which are including the Boolean expressions. So all this help in our semantic analysis, which is the third phase of our compiler. Thank you, students.